This is Mrs. Gilbert. Today's lesson is an introduction to trigonometry. Trigonometry is a Greek word that means triangle measure. We can use trigonometry to find the unknown sides or unknown angles in a triangle. Today we'll only be talking about right triangles. We need to be able to identify the sides of the right triangle. We have the hypotenuse across from the right angle. We have the opposite side, which is across from angle B. And we have an adjacent side to angle B, which connects into the vertex. The sine, the cosine, and the tangent are ratios between two sides of a right triangle. The angles are related to the ratios. In this right triangle, I have angle A. I have the side across from A is 2, and the adjacent side is a 10. The ratio in this case would be 2/10. If I increase this side to 4, the angle A became larger. Take a look again. Angle A is across from the 2. If I increase the 2 to a 4, now my ratio changes. I've kept the 10 the same. I could increase the 4 again to a 6. So as I increased this side, the angle became larger each time. So the angles are related to the ratios of the side. The information that I know will determine whether we want to use a sine or cosine or a tangent. Today we'll only take a look at the tangent ratio. The tangent of angle B, over here, is the opposite side over the adjacent side. Notice I abbreviate the word tangent to 3 letters, tan. I can also use the first letter of each of the words tan, opposite, and adjacent to come up with T equals O over A. Let's take a look at the 45, 45, 90. The opposite side is across from the 45. The adjacent side in this case is a 5. And if I wrote the opposite side over the adjacent side, I have that the tangent of 45 is equal to 1. That's going to happen in any 45, 45, 90-degree triangle. I have a larger triangle, but when I put the opposite side over the adjacent side, I always come up with the tangent of 45 equal to 1, no matter what size the triangle is. Same thing happens with a 30, 60, 90-degree triangle. We have the side opposite 30 as 5. The adjacent side is 5 times radical 3. When I put the opposite side over the adjacent side, I have that the tangent of 30 is 5 over 5 root 3. I can put this in my calculator with parentheses around the denominator and come up with this decimal, 0.5774. We normally use 4 decimal places when we're doing trigonometry. Here I have another 30, 60, 90-degree triangle, but it's larger. And in this case, the tangent of 30 is still the opposite side over the adjacent side. And when I divide this on my calculator, I get the same decimal, 0.5774. It doesn't matter what size the triangle is. My tangent of 30 degrees will always give me the same value. And then I can use that to find sides of a triangle. How do I use my calculator? Let's take a look at the mode button. It's over here at the top on the left side, and we need to make sure we're in the correct mode. So go ahead and press the mode button on your calculator, and you'll get this kind of a menu. And when you look at the menu, The third line down says radians or degrees. In this course, we'll want degrees, so you would use the arrow button and you would scroll down and over until you are on the degree, and you want to press enter, and that will be darkened. In later courses, we will use radians. Let's find the tangent of A. We're simply looking for the ratio of two sides. We know that the tangent of any angle is the opposite side over the adjacent side. So let's go ahead and look at angle A. And I see that the opposite side is 3, adjacent is 4. So the tangent of A is 3 over 4. Same triangle, but this time we're looking for the tangent of B. So I'm looking for a ratio, a fraction. Here's my angle B, but this time the opposite side is 4 and the adjacent side is 3. So the tangent of B is 4 over 3. This is the reciprocal of the tangent of A. How do I find a missing side? If I am working with the opposite side and the adjacent side, and it is a good idea to label those sides with those words, I'm going to select the tangent ratio because that's the one that uses the opposite and adjacent sides. You're going to write that the tangent of the angle, 33 degrees, is equal to x, which is opposite, and 20, which is adjacent. Now I'm just going to use algebra to solve for x. In order to eliminate the 20, I'm dividing by 20. The opposite is to multiply both sides by 20. When I multiply x over 20 by 20, I'm left with just x. On the left side, I can evaluate this by putting it into my calculator. Press 20, tangent 33, and you should get 11.5. That's an answer that has been rounded off to the nearest tenth. Final answers are rounded to the nearest tenth. How do I find x in this case? Again, I'm looking at the adjacent side and an opposite side. I know I want the tangent ratio. Sometimes, if the hypotenuse is involved, we'll find out later that we might be selecting sine or cosine. The tangent ratio uses the adjacent and opposite, so let me set up my equation. The tangent of the angle is equal to x over 9. I want the x alone, so I'll multiply both sides by 9. On the right, x divided by 9 multiplied by 9 gives me just x. You can put the left side into your calculator, and you can round off your answer to the nearest tenth. Occasionally, you may want to round your answer to the nearest hundredth or thousandth if you're trying to be more accurate.